Radical operations. So first we're going to add and subtract radicals. Adding and subtracting radicals is very similar to combining like terms. So you're going to be looking for like radicals that can be combined. So for instance, problem number 1, we have 3 root 5 plus 9 root 5. These are both root 5 problems, which means they have a like radical. So we're going to leave the root 5 alone, just like what we do when we're combining like terms. And if I have 3 of the root 5s and I add 9 of the root 5s, I have a total of 12 of the root 5s. So your root stays the same, so that stays the same, and you add the coefficients of your roots. Same thing if you're going to subtract. So these are both root 7s, so those are like roots, so I can have root 7. And I have negative 8 of them minus 4 of them makes a negative 12 of them, so negative 12 root 7. It's a complete coincidence that they're both 12s, by the way. Okay, so if you have like roots, you can just do your combining, adding or subtracting, leave the root the same. Now, if your roots aren't the same, you have to see if you can simplify. If you can't simplify and they're not like roots, you can't combine them. So this one has a root 5 and a root 20. Those are not the same roots. However, I can simplify the square root of 20. So think back to our simplifying roots. So I'm going to say what two numbers multiply to 20, and that could be 4 times 5. Well, 4 is a perfect square, so I'm going to leave that alone. That's a good answer. So I'm going to do a little bit of side work down here. So the square root of 20, or 2 root 20, is the same as 2 times 4, the square root of 4 times 5. Well, I know the square root of 4, that is 2. So I have the 2 that was already there, times the 2 that came from the square root of 5, and, sorry, the square root of 4 and the square root of 5. Well, together, that means that it is 4 root 5. So now my problem says 4 root 5s plus 10 root 5s, and that is something I can combine. They're both root 5s, so I'm going to have a root 5 in my answer, and 4 plus 10 is 14. So that's 14 of the root 5s. And again, I'm doing all of the work for right here. If you can simplify it a little bit more, go for it as you go through it. So let's try another one. 10 root 3 minus 2 root 27. Again, our roots do not match. Can we simplify? Well, we can't simplify the square root of 3 because 3 is prime. So let's try the 27. 27 is 9 times 3. So I'm going to do some simplifying of my 27. So I have 9 times, 3, meant to write 3. I can simplify the square root of 9. So that is 3. And I still have a root 3 with a 2 in front. If I combine those, I get 6 root 3. So now my problem says 10 root 3 minus 6 root 3. My roots match, and 10 minus 6 is 4 root 3s. So I have now combined my common roots. Okay, multiplying radicals. This gets into now multiplying. We're not doing dividing because we already did. That was called rationalizing a denominator. With multiplying radicals, this is very much like the like terms. You can multiply square roots with square roots, and you can multiply the integers, which kind of look like the coefficients, with the coefficients. So you can't multiply a coefficient with a square root. It doesn't work. So it has to be like things that can be multiplied. And then at the end, you're going to simplify. So for instance, if I had the square root of 4 times 2 root 4, the 2 is the only integer out front, so I'm going to leave that alone. But I can multiply the square root of 4 times the square root of 4. So when you do that, you're going to multiply the 4's. So 4 times 4 is 16. However, I can finish this and actually simplify it further because 16 is a perfect square and the square root of 16 is 4. And to finish this problem, 2 times 4 is 8. So we multiplied the roots together to get our root, and then we simplified. Okay, this problem right here, we have 2 root 3 times 5 root 6. So first I'm going to multiply the integers, those coefficient integers, and 2 times 5 is 10. And then I'm going to multiply the roots together. So the square root of 3 times the square root of 6 is the square root of 18. 6 times 3 is 18. We can simplify this because 18 is 9 times 3. So that means that we have 10 times the square root of 9 times 3. Just like our homework was simplifying, the square root of 9 is 3. And we still have this root 3 right there. And our final answer, 10 times 3 is 30 root 3. So our final answer for that one is 30 root 3. Okay, for last night's homework, here's your answer key. You can always pause this video and check your homework. So it is going to be due tomorrow by 5 a.m. I do have tutorial today from 1 to 1:45. So if you have any questions about this, you can show up. And I will see you all on Friday.